go over EKS. Okay, thank you for those who joined. Let's get started, huh? Okay, so the way we're gonna do it is, I'm gonna go through the theory, and then I'm gonna start the demo when I create the cluster, and then when the cluster is creating, I'll take some question and answer. It takes a little bit of the time for EKS Auto to get the cluster. Okay. Good call. Okay. Thank you, Ahmed, for saying. I had no idea music was still playing. Can you guys and girls hear me okay now? Okay, hello, Rakesh. Yes. Yes, good, okay. Dano Data, thank you for being a member. Thank you for joining. I know this is Saturday. I don't know where you guys are based out of, but where I'm in like New Jersey, and it literally snowed like a lot, okay? So, so after this, I gotta go shovel. But I thought a lot of my customers are asking about this EKS Auto. So I thought, hey, why don't I do a live stream? So I also get some practice, because next week I have to present this to a bunch of customers. Okay. Okay, all right, sounds good. Shall we get started? You guys can hear me, by the way. Can you hear me okay now? The music is gone, hopefully. Okay. I'm gonna wait to see if you folks can hear me. Okay, Nilesh said yes, that's good, thank you. Thank you, Nilesh, for confirming. Loud and clear, Dano Data, love it. All right, let's get started. Okay. So, EKS Auto was released this reInvent, right? And this is a relatively new feature, but it's still under EKS. So we're gonna go over all over it. For those of you who don't know me, my name is Raj. I'm a principal solutions architect at AWS, where I have been working there for 6 years. I have migrated many critical projects to production for both Kubernetes, serverless, and general AWS. Also a best-selling author and a public speaker. And previously before joining AWS, I was a distinguished cloud architect at Verizon, where I migrated many applications to production. Okay, so this is your current EKS cluster, right? So let's say you have your control plane. So let me take my handy pointer. So you have your control plane, and let's say it's running with version 1.30. This part is managed by AWS. And then you have your data plane, where you provision the EC2s, and you are using Amazon Machine Image for version 1.30. All three are running with the same AMI. And inside these EC2s, the pods are running, which is running your application. But you don't really start from here, right? Before you can run your workload on EC2, you need to install some add-ons, right? Your cluster needs auto-scaling, observability, networking, etc. So what do? When you create the cluster, you also create a node group, and then in that node group, you run 1 or 2 EC2 instances, and in those EC2s, you install those add-ons. For example, Carpenter, Ingress, Storage, Core DNS, etc. Right? So if you need to install more add-ons, you just go and install it. So at the end, you end up managing these EC2s, which is running your add-ons, as well as your worker node EC2s. Okay? So, and then not only that, you also need to manage your add-ons. So if a new add-on version comes out, you need to test. Let's say Carpenter came out with version 1.1. You need to test if that version 1.1 is compatible with this version 1.30, test it out, upgrade it, all that stuff. So it puts a lot of overhead on your plate. So let's say down the line, you go and upgrade this to version 1.31, right? You go upgrade control plane. you need to test and upgrade the add-ons, the upgrade AMIs, all that stuff. So for some of you today who are using cluster autoscaler, you need to update the launch template, you need to run recycle commands, all that stuff. So what if you just want to run your application on EKS and not worry about all this management overhead? You know what, I'm like, okay, I have my deployment manifest, right? All I want to do is just run that in a Kubernetes cluster where AWS manages most of the things. I only worry about my application. So this is how EKS Auto was born. So let's understand what EKS Auto is. Okay, let's see. All right. So currently this is how this is running: manage add-ons, manage AMIs, right? Now with EKS Auto, AWS manages the core add-ons. So for example, Carpenter, Ingress, storage, we as in AWS run on the control plane, right? And what that means is we make sure they're highly available as well. And if there is a security vulnerability, we go and patch it. But then you are like, okay, we still have these EC2s. What do we do with those? Not really. With Amazon EKS Auto, AWS also manages these Amazon EC2s. So these are all managed instances. You don't need to select an AMI. You just run your workload. Okay? At this point, you are like, but how about some of the other add-ons, Raj? You have this Core DNS add-on here. That's also managed by AWS. So for the components that need to be run on worker nodes, right? For example, VPC CNI components or kubeproxy, AWS bakes them into these managed EC2 instances. And they don't run as daemon set, because daemon set has to go through some processes. Like before you run a daemon set, it goes through the webhooks. You can control how they run. So, and it's also a little bit more heavyweight. With this, AWS runs Core DNS, VPC CNI kubeproxy as systemd process and not daemon set. So this is how it looks like. The essential add-ons, when you create EKS Auto cluster, AWS installs it and manages it. AWS makes it scalable, highly available, and secure. The worker nodes also, AWS manages it. And by default, no worker nodes run. And you'll see this in example in a little bit when we do the demo. When you deploy an application, that's when AWS will create these worker nodes. And these worker nodes, you do not need to select AMI or nothing. AWS manages the whole thing. Okay, so and as more worker nodes come in, they will come and basically they will populate and all that stuff. And AWS also optimizes that. So for example, in this case, this pod is running in this EC2, this pod is running in this EC2, but this EC2 is 50% underutilized, right? So with EKS Auto, AWS will move this pod here and terminate this instance and save you a bunch of money. So basically AWS manages most of the things. Okay, so hopefully this is making sense. So let me see one thing. Give me 1 second. Okay, now I'll pause for questions and stuff. Let's see. If I go here, so if I go here, I'm just checking my slides. Okay. Okay, good. Okay, so since we are all here, I'm also going to go through the difference with Fargate. So at this point, some of you might be like, okay, this is very similar to Fargate, right? With Fargate, you just deploy your manifest file and AWS basically manages the underlying infrastructure. But there are some big differences with Auto and Fargate, okay? So if I go to Fargate, Fargate does not manages those add-ons, right? You still need to have those add-ons. like you still need to figure out a way to run Carpenter and all that stuff. Okay. With Fargate, how it runs is you create one Fargate instance and then you run one pod in per instance, right? Because in Fargate, you can only run one pod per instance. So basically, you need to figure out how to run those add-ons, and you also need to manage them. Next, so this is one of a big thing that our customers tell us. Fargate has some consideration. The biggest thing is with Fargate, you cannot run daemon set. But remember, EKS Auto at the end of the day is running on EC2, and we are just managing the EC2. So you can run daemon set, and you have all the flexibility of running other processes that you generally run on a EC2. Okay, so with EKS Auto, AWS manages the core add-on, AWS manages the AMIs. So AMI is bottle rocket based, right? You don't need to manage anything. Managed worker nodes are EC2s. What that means is, unlike Fargate, you can run daemon set. Okay, and unlike Fargate, you can run any instance type, including GPU, because Fargate, EKS Fargate, you cannot do GPU. But because this is regular Amazon EC2, you can pick any EC2 type you want, GPU, memory optimized, storage optimized, anything you want. And you can run service mesh. For a lot of our customers, they run Istio, and service mesh that like Istio are not supported in Fargate, right? Because Fargate does not run on EC2s, it just runs one instance per pod. You can run service mesh or any tools that run on pod or sidecar in EKS Auto. And like I was saying, EKS Auto constantly optimizes to save you money. So in this instance, the first instance is really nicely bin packed, but the second and third, there is 50% underutilization, right? Because this pod is running in this instance, this pod is running in this instance. EKS Auto will bin pack these pods and terminate the other EC2, saving you more money. Okay, so if I go forward, EKS Auto automatically right sizes EC2 and saves you money. So EKS Fargate does not right size automatically, right? Because when you create Fargate, you need to say this Fargate instance need to run with this much vCPU, this much memory. But, so if I go back to the Fargate slide, right? Let's say, where is my Fargate? Here. So let's say you allocated 4 vCPU here, 4 vCPU, and 16 GB of memory. But if this pod does not need all that, you are still wasting it, right? So, but with EKS Auto, it will constantly bin pack the pods and make sure it's optimized. Okay, let me go forward where we are. And then I'm going to answer questions when I start the demo. I see there are some questions coming in. Okay, so EKS Fargate does not right size automatically, but EKS Auto does. Also, because EKS Auto is basically running EC2 managed instances, you can implement reserved instances, savings plan, and Spot. Yes, you can also use Spot in EKS Auto. And you can tell, hey, AWS, you still manage my instances, but I want them to be run on Spot. Okay, so going forward, how about upgrading the control plane? So Dano Data says EKS Auto installed in new EKS. No, it could be in existing, right? Well, I'll show you in the demo. Okay. Now you are like, okay, Raj, this is good. AWS is managing all that. How about upgrade? I still need to go through pain of upgrade. Well, here also we do a lot of things. You control the upgrade. We do not go and upgrade your Kubernetes cluster, by the way. Okay, you still control that part. So with EKS Auto, and you could see on the top right, whenever I'm talking about EKS Auto, I have put EKS Auto. If you come and upgrade the control plane and managed add-ons are updated automatically. So this part is nice, right? So you upgrade this, you don't have to worry whether these add-ons will work with the updated control plane or not, because AWS test with EKS Auto, AWS is testing all these add-ons make sure they're compatible with the new versions. And it's intelligent enough to know, let's say when you upgrade from version 1.30 to 1.31, maybe Ingress has a newer version to work with that new Kubernetes version. AWS will upgrade this Ingress version. But let's say Carpenter has the same version for both Kubernetes version 1.30 and 1.31. It will not upgrade the Carpenter. It will only upgrade the Ingress. So, and it also ensures that it works with the new Kubernetes version. Not only that, as soon as you upgrade it, and then let's say you deploy new workload, the workloads are also upgraded by AWS in a rolling deployment fashion. So in this case, so if I go here, you go and upgrade the control plane. So how does rolling deployment fashion work? AWS will create a new Amazon EC2, which is also managed for the new version, right? Not the old version. And then it will basically drain and cordon the existing EC2. So these pods will come here. Similarly, it will upgrade the other AMI and the pods will come here, right? So if we go back to our thing, EKS Auto updates core add-ons automatically with control plane upgrade. Okay, so now it just goes and updates all that stuff. Also, to get security compliance, EKS Auto also recycles the nodes every 15 days. So even if you have not upgraded the control plane, by default, EKS Auto will run this process of upgrading AMI every 15 days. You can change it to maximum 21 days in rolling deployment fashion, right? So just to explain this part a little bit, let's say you just upgraded the control plane and the worker nodes got upgraded too in a rolling deployment fashion. So let's say this is 1.31, this is 1.31 AMI, right? And this AMI version is, let's say, Bottle Rocket, so BR, let's say 5.0, just for example, okay? And then let's say AWS put some patching and stuff, and then we released version 5.1. So in 15 days, it's up to you, it can automatically do it too. In 15 days or 21 days, it is going to migrate these instances to 5.0 to 5.1 for same Kubernetes version, right? So it automatically keeps your worker node zero touch and highly compliant. Okay. All right, let's do some demo. Let me go to, okay, so how do you get started? Okay, so see here, if I go EKS, all right, so you can do this from CLI too, but I do a lot of stuff from CLI, so I think it will be a little bit more fun to show you on the console itself. Okay, so create cluster. Okay, keep this as is, keep this as is, and you can create these roles. So I am actually gonna create a new VPC. Okay, let me create a new VPC. Create VPC, so it's easier for me to delete. Okay, auto tag, VPC. YouTube Live project. Okay, how about this? YouTube Live dash project. Okay, come here, create VPC. Okay, so it's creating the VPC. Should be pretty quick because then it's easier for me to go and delete and stuff. Okay, the VPC is created. So if I go here, refresh it. Okay, YouTube Live project VPC. And look, by default, it selects the private subnet for security because all the worker nodes is gonna come up in the private subnet, not public subnet, right? Okay, let's see, click create, click create. Okay, let me click create and then I'm gonna answer some questions. Okay, so this is gonna take a little bit of time and you will know this because look, okay, this spinning thing will stop. Okay, let's see. Okay, Krishna. Hey Krishna, how's it going? Okay, hi Krishna, hi Raj, Krishna here. Quick question, what happens to the add-ons in the existing cluster, if we yeah, so they will all get evicted based on your add-on. This is a good question. So with EKS Auto, so if you go and switch an existing cluster to EKS Auto, the control plane will have those add-ons, but then you need to ensure that the existing workloads that are running, it's not going to delete your existing nodes basically, right? So just to be clear, if you go do EKS Auto, your existing, depends on your tension toleration, I think they will still run. That's actually a good question. Let me note this down, Krishna. See, this is the good thing about doing the YouTube live, because before customers ask me this question, you guys are asking me this question. Okay, let me note it down. Okay. Okay, let's say. Okay, and I think in an existing cluster, there is a toggle switch using which you can change it. Let me see if there's anything in the documentation. Okay, let's see. Okay, let's see. EKS Auto. EKS Auto documentation. Okay. Let's see. Enable existing cluster. Here we go. Okay. Migrate volumes, migrating Carpenter, migrating EKS managed node groups. Okay, this is the main thing, right? Migrating from EKS managed node group. Okay, let's see. You can smoothly migrate existing or managed node groups using EKS. This process ensures continuous while the migration can be performed safely. Drain pods from your cluster with EKS Auto for infrastructure procedure. Okay. Okay, so basically you have to drain it. So what that means, Krishna, is we are not going to touch it. So if you go and switch your existing cluster, so let's say if I do this, and then I gotta test this out. Okay, delete. Okay, let's say this pointer option pane. Okay, so basically this is your control plane, and then your worker node, this is worker node. So let's say this is the managed node group. So we'll put it M and G. Okay, and this is EC2s, and let's say these are your add-ons. Okay, these are your add-ons. Okay, and then the worker nodes are running your regular EC2. Okay, this is where your pods are running. So even if you switch to EKS Auto, we are not going to evict this. So you need to use labels to specify which ones are running when the newly switched EKS Auto. Okay, but as soon as you switch, we will install the add-ons on control plane as well. Okay, so that is how this will work, but I need to test this out before I'm gonna put it on the comment. Okay, let's see, run workload, deploy infinite. Okay, yeah. Okay, create node pool, how it works. Yeah. Okay, let's see. Any other questions? Okay, and it does have a price. So EKS Auto, because we are managing all this, we are gonna charge 12% of the on-demand price. Okay, so let's click this. Okay, it's still creating. It takes a little bit of time. We should show a little bit of progress. Okay. Is this too small? Can you guys see my screen well? I mean, should I make it bigger? Let's see. There we go. It's probably a little bit better. Okay. Okay, so we are creating the cluster, and I'm going to use Cloud Shell to access this. So let me go to Cloud Shell while that is doing it. I want to see if everything is installed. kubectl get nodes. Okay. Okay, good. So kubectl is installed. So one thing is I'm using Cloud Shell, folks. So Cloud Shell is you click here and it creates a shell. if you use Cloud Shell, you need to go install kubectl and eksctl and all that stuff. Okay. Okay. Hopefully this is making sense. So I see some of you folks are online. Dano Data, Harsh, Krishna. I think you already understood the value proposition of it. Did the value proposition make sense? Like what does EKS Auto does and why it does it, right? And what things it takes away from you. Okay, I hope that was clear. Okay. Let's see, 15 watching. Okay, let's go here. Let's see. It is taking some time, isn't it? Okay, so while it is doing that, we are going to do one thing. So see, currently EKS Auto, remember it follows the AWS best practices. So what that means is, so let me go, erase all slides, erase all link. So what it's doing is, in the VPC, you have a public subnet. So this is public subnet, okay? And you have private subnet, right? Private subnet, okay? So let's say this is EC2 running on public subnet. This is EC2, okay? And the private subnet, also you have EC2, EC2, okay? So all the worker nodes on EKS Auto will be created on private subnet, right? So by default, EKS Auto, let's say this is the internet, okay, this is the globe. By default, EKS Auto cannot reach to the internet, right? Because this is private subnet. So what do we do so that this EC2s in private subnet can reach the internet? We need to create a NAT gateway, right? So we need to create a NAT gateway, and this private subnet route table, so I'll say route table, needs to have a route. So whenever a container is trying to get created, this container should have a way, this EC2 should have a way to go to the route table, say, hey, I need to go to the internet. It says, oh, you need to go to the internet. If you need to go to the internet, go to this NAT gateway. And this NAT gateway, go to Docker Hub or whichever repository you are using to grab that container image and then get it back to the EC2, right? So while it is creating that, let's go create this NAT gateway, else it is not going to work. Okay. So if I go here we go. Let's see, NAT gateways. Okay. Create NAT gateway. Okay. YouTube Live NAT gateway. Okay, now subnet, we need to select the public subnet for the YouTube Live, right? So let's put YouTube Live project subnet public one. Okay, and then I also have to allocate elastic IP so that it can go out. Okay, let's see, YouTube Live project subnet. Okay, I think this should do it. Create NAT gateway. Okay, it's pending. Okay, will this live be saved? Yeah, it will be saved. Did that part make sense, by the way? Krishna, did that part make sense why we created NAT gateway? I don't know if you're still here. Okay, because by default, these EC2s, yes, right, okay, good. Good to see you here, by the way, Krishna. Yes, Dano, yes, thank you, okay. Because without this, you will see containers are gonna be failing, create failing. Okay, so let's go here. Let's go to EKS, open link in new window. Let's say EKS, Kubernetes service. Okay. Let's say it's still creating. It is taking a little bit of time. So far, so good. Tulsi, you are here too. Okay, welcome. Okay. And you can practice this out, use this in your social media and stuff. Yes. Okay. Any other question on EKS Auto or Carpenter in general? Let me know. You all voted in LinkedIn that you wanted to see EKS Auto, so I'm doing EKS Auto, but I'm open to doing a Carpenter hands-on workshop as well in YouTube Live. So I'll do that down the line. Probably should have created the cluster beforehand, huh? This is taking a lot of time. Come on. Tulsi, lot of snow down in Texas. It is crazy, man. It snowed in New Jersey, but yeah, my friends are in Texas and they're saying like it's crazy how much it snowed. And then in LA, there is like crazy fire going on. I don't know what's happening in the world. It is not good. Okay. Let's check out the LinkedIn. Let's see what's going on LinkedIn. Okay. Nothing crazy. Okay, let's go back here. Okay. Yeah, fires is crazy. That's like kind of sad to see. Because LA is like some parts are very, very nice, right? Okay, so the EKS auto mode cluster is created because the spinning stopped. So let's get to the action. So for those of you who don't know, so if you click this, it will open this Cloud Shell. And we need to update the kube config so that we can access this cluster. So if I do EKSCTL get cluster, oh, I need to install EKS, but that's fine. Okay, let's do this. AWS EKS update the kube config dash name. Okay, what is the name of the cluster? Come on. Link a new window. Okay, let's take a Kubernetes service. Okay, amazing Electro Crow. Okay, come on. Okay. AWS EKS update dash kube config. Name this, okay? What do I do? Update AWS EKS. Oh. What is going on with this? Okay, here we go. Okay, this is good. So if I still do kubectl get nodes, so this is the cluster that I connected to. See, no resources found. So this is the thing I was talking about. When no workloads are running, EKS Auto does not create a worker node, right? It only creates when there's a workload running. Okay, so let's grab a sample workload, maybe hello world or something. Okay, deploy inflate workload. Okay, let's do this. Deploy a sample application. Okay, so I'm gonna copy this. Okay, notepad, inflate YAML, okay, file, save as, I'll save in desktop, okay. Okay, let's see, inflate. Inflate.yaml. .yaml, click save. Yes. Okay, so I saved it. So if I go back to this, I keep losing it. Where is this shit? Okay, here, okay. So now I'm going to upload the file, upload file, downloads, inflate.yaml, click open. Okay. Okay, already exists. Okay, that's fine. ls. Let me just rename this. Download, inflate, rename, inflate underscore 2. Okay. Action, inflate underscore 2, open. Okay. So we are basically uploading the workload. So if I do ls, so I should see inflate underscore 2. So if I do cat inflate underscore 2 dot YAML, what? Okay, do inflate Oh, I mistyped it. Cat inflat. Okay, here we go. So the YAML is here. Okay. So now I'm going to deploy this. Okay, kubectl apply -f inflat _2 .yaml. Okay, so if I do this, deployment created. Okay, kubectl get pods -a. Okay, see, this is pending container creating. Okay, so there was nothing there, but now as soon as I created a workload, deployed the workload, EKS Auto is like, okay, I know what type of EC2 instance to create, so that's what it's doing. So kubectl, remember before I did kubectl get nodes, it was blank, but something should be coming up now. Okay, great. See, now there are 3 nodes coming up, right? And AWS automatically selected the AMI. I did not need to select anything, okay? So it's doing it all based on the workload. It automatically selected the EC2. So if I go to EC2, so if I go EC2, let's say EC2, instances, boom, see, 3 EC2s came up, and AWS automatically created this as C6G large because it thought, okay, that's the best instance based on the workload. Okay. Load balancer. Okay. Ahmad said, do we need to install load balancer controller? No, you do not need to install load balancer controller. It's automatically installed in the control plane. So you can just deploy your ingress resources and it will start, like it will provision a load balancer and it will go do the path, all that stuff. So you don't have to, we don't have to go install and manage load balancer controller. Raj, for BinPack, would it EKS? Yeah, good question, Krishna. EKS Auto uses Carpenter on under the hood. So it's actually using Carpenter consolidation for bin packing, right? That's what it's doing, basically. Good question. Deno data, you don't set a mean or max scaling for worker nodes? No, but because this is not an auto scaling group, but this is working on Carpenter node pool. So you can create your own node pool and you can define the max. So basically, you could say, okay, only keep on scaling till the number of vCPUs reaches this, because you don't want your builds to be crazy, right? So when it comes to EKS Auto, it has default node pools, general purpose node pools that it comes with, but then you can override them and you can write your own Carpenter node pools. Okay, let me see if I can show you guys. Okay, enable existing cluster. Okay, configure, create node pool. Let me see, sample node pool. Okay, yeah, so you can create these limits with your own node pool. Is there a way to see? I have it on the slide. Let me show you the slide, okay? Download Cube 312, okay? Okay, let me show you the general purpose node pools, okay? Let's see, I have it somewhere. This is the presentation I did in reInvent, basically. Control. Okay, where is the node pool? Okay, here we go, general purpose node pool. Okay. Okay, see, by default, this is what EKS Auto comes with. So if you see this, there is no limit in this one, but there is no weight either. So you can create your own node pool to override this. So by default, it can only spin up C, M, or R. And if you have specific, if you know your application needs to use GPU or something, you can create another node pool, give it a higher weight, and then basically your node pool will be taken over. Does Carpenter? Yes, Carpenter set the EC2 instance type, but you can specify, for example, this is gonna specify between C, M, or R, or you can keep it blank. You can avoid saying anything. Then Carpenter will pick the best EC2 instance type from over, I don't know, 200 or 300 or how many instance type we have now. Yeah, but yeah, so this is optional Dino data, right? So it comes by default, it comes with that, but you can define your own node pool and you can say, hey, I don't want to specify this. So Carpenter then will consider wide range. Okay, let's see. Ahmed, I mean standalone load balancer instead of ingress resource. For managed node, we need controller, target group binding for auto mode. Yeah, so basically for EKS auto, it's running the load balancer controller in the control plane, right? And basically you have the ingress, you can define ingress resource, it will create the load balancer, you can use target group path binding, all that stuff. We have an example here. Actually, I added this to my Udemy lectures as well. You can check it out. So here it shows how to do that. So we have an example for that. Okay, let me go back. Okay, then I want to show you one thing. Okay, preparing your terminal. Okay, so now I'm gonna delete this and it should delete all the pod. kubectl get pods -a. Okay, so all this is running. Okay. Okay, some got error. I have no idea. kubectl get pods. Okay, so that inflet. Ooh, that is not good. Error image pool. I thought I created the thing. Okay, it also shows there. Let's see here. Okay. Resources pod. Okay, let's see one of these. Annotation. Exceeded. Oh, I know why. Why? We did not create the route table, right? We created the NAT gateway, but we did not create the route table. Okay, okay. Let's go create the route table. Okay. Okay. VPC. Let's go VPC. Okay, your VPCs, YouTube Live Project VPC. Okay. So here, let's see. We need to create route tables. Where are the route tables? Route tables. Open window. Route table. Create route table. Okay. Route 1, select a VPC, YouTube Live VPC. Okay. Oh no, okay. What's going on? There should be already be route tables, okay. Okay, so the private subnet route table ID. Okay, I just need to update this. Routes 00 black hole. What the heck is black hole? Oh, okay, YouTube Live. Here we go. Routes. Edit routes. Here we go. Okay, add route, internet, and then we have to do NAT gateway. Okay, this is the YouTube Live NAT gateway. RTB. Okay, good. Okay, we need to do another routes. This is 0A0C0. Okay, we have to do the other subnet. Private one. Okay, here we go. Routes, edit routes, add route. So you have to send it to internet, right? NAT gateway, NAT, save changes. Okay, now it should have the route. It should have the route. Okay, let's see. See, I'm not used to this Cloud Shell. Generally, I do Visual Studio IDE, but this is easier. Okay, let's just delete this. It should automatically try, but I don't know if this will delete -f inflate underscore 2.yaml. Okay, now let's try doing this again. kubectl apply -f inflate underscore 2.yaml. Okay, deployment created. Okay, kubectl get pods -f. Well, you guys and girls got some live troubleshooting, right? Because we went before and everything was getting error. No container was running, right? And then I went to see the events, which shows in the console. I could have also run the commands here. And it said it's not able to fetch the image from the repository. So then we figured out, okay, so even though we created the NAT gateway, but we did not put it in the route table. The private subnet, the route table, should have specified that anything that's going for internet, route it to the NAT gateway, and then the NAT gateway goes out. And as soon as we did that, it worked. Hopefully it works. Okay, kubectl get pods. Let's see. Okay, so the inflate is running. Okay, so this should fix itself now. Get pods -a. Yeah, this should all fix itself. Yep. So else everything would be giving error. Okay, so now I'm gonna delete this, and it should go and delete these instances as well, right? Because it automatically scales down basically. Okay. Let's go here. Is it making sense, by the way? Krishna, Tulsi, Dano Data, making sense? Like why the error was giving, and how by changing the routes it went to the internet, how in the beginning there was no EC2s running, right? Only when we deployed the workload, the EC2s came up, and now when I delete the workload, the EC2s will go away and you are not going to pay anything. Okay, and Krishna, I'm gonna get back to you on switching the existing cluster. I need to make sure I understand that properly as well, because customers are definitely gonna ask me those. Okay, so good question. Okay, let's see. Okay, so now kubectl delete -f. What do I do? Inflate underscore 2.yaml. So Ahmad, I see you have questions on Ingress, so hopefully it made sense. Just I'll put a link to the Ingress exercise and you can go try it out. Or you can also check out, if you have my course, you can check it out too. But you can go and see how the Ingress works. You can run this here and it will create the basically load balancer and stuff. Okay, kubectl delete -f inflate 2.yaml. Okay, so here kubectl get pods. Okay, it should be starting deleting. Okay, it's deleted. So let's see if there is a time that is gonna wait. Okay, let's see. Consolidate after 30 seconds. So this is using the default node pool, right? So it is going to wait 30 seconds, and then if the node is empty or underutilized, it's basically gonna delete this. Okay, 10% at a time. So if we go here, it should, there was 3. See if I refresh, it should start deleting. Okay, see, it already deleted 1. There were 3 running, but now only 2 are running. That's cool, right? So you don't need to worry about, oh, I'm not running my EC2. I'm not running any workload. Will EKS Auto still be charging? No, it's like kind of pay as you go model. So as soon as your workloads are done, it's gonna go and delete the stuff. Dano Data said, no, you cannot define your own AMI in EKS Auto, because EKS Auto, so if I click this, I wish I showed you this before, it runs with BottleRocket AMI. So BottleRocket is CIS level 1 compliant, but it is not STIGged. So if you need to use STIG, so you can use custom AMI. In that case, use open source Carpenter basically. So in open source Carpenter, you can use the node class to create any custom AMI, to use any custom AMI you want. So you can still use this. EKS Auto by default only runs bottlerocket and you cannot override the AMI. Okay. Okay, so platform detail Linux Unix. I think it shows bottlerocket somewhere. I mean, I could have run a command before too, but now it's all gone. But hopefully that answers your question, Deno Data. Okay, so let's see. It should start deleting all this. Okay, let's see. Unless I'm running this in some other cluster. Okay. kubectl get nodes. Okay, even though it says 3, but one is already deleted, it's running a little bit behind. Get nodes, come on. Wait, what? kubectl get parts dash a. Those are the system parts. They should get deleted. Interesting. Okay. Okay, Dano, you got your answer. Okay. Let's see. Yeah, it should get deleted itself. I tested this last week. I don't know why they're still keeping running. Okay, kubectl get deployment. How about we check the deployment? No resources found. Dash a. Cube system. Yeah, it should delete itself. Okay, default Amazon Guard Duty. Yeah, this part it should delete. It will probably delete. It just takes a little bit. Come on. It says initializing, which is kind of weird. But anyway, so I'm gonna check this, and if you try this at home, make sure you delete the cluster and stuff, because you're gonna keep paying for the control plane as well as the NAT gateway. NAT gateways are very expensive, so I'm actually gonna go delete the NAT gateway, because NAT gateway you get charged not only based on how much data is going through it, but also per hour charge. Basically, you get paid, like you pay whether you use it or not. Okay, let's see. Delete NAT gateway. Delete. Okay, and then I also have elastic IP, right? Elastic IPs. Okay, let's delete this elastic IP. Okay, release elastic IP. This is remove the association by action dissociate. Okay. Dissociate. What the heck is going on here? Update enable. Okay, I gotta take care of this elastic IPs. Okay, folks, thank you for joining this live stream. I know this was a little bit short and sweet, but hopefully EKS Auto made sense how it works, and along with the demo, hopefully you all try this out. Currently, this is only available in the commercial region, not in the Gulf Cloud. So Deno Data seems like you work in the compliance space, because you have been asking stuff that my compliance customer asks. So yeah, for you, if you are running it in Gulf Cloud, EKS Auto is not in Gulf Cloud yet. You can run regular EKS cluster with Carpenter open source, and then you can use your custom AMI. All right, folks, that's it for this one. Thanks for joining. Enjoy the rest of your Saturday. I'm gonna go shovel some snow. I'll see you all in the next one. I work in the Gulf Cloud. Yep, that's what I figured. Okay, good. And